Last class, we have studied about various parts of a DC machine and its functions. Discovery of laws of electromagnetic induction in the year 1831 by Michael Faraday paved a way for generating electricity. Electric motor and generator works on the principle of law of electromagnetic induction. This class, we will study about the principle of operation of a DC generator. The three essential components required to generate a dynamically induced EMF are magnetic field, conductor, relative motion with respect to magnetic field. The relative motion implies that flux is stationary or the conductor is moving, or the conductor is stationary and the flux is moving. If we keep any one of these, we can keep either the flux is stationary or the conductor moving, or the conductor is stationary, the flux is moving. We may able to generate a dynamically induced EMF. In order to understand the operation of a DC generator, let us consider a simple DC generator with singleton coil. Let us draw the tane. Each tane consists of two coil sides. One is coil side 1. Coil side is also called as a conductor. Coil side 2. This refers back end connection of a coil. This implies the front end connection of a coil. Back end connection, normally we call it as a overhang portion of a conductor, which will not contribute for generation of EMF. Front end connection, normally we connect to commutator segments. Referring the diagram shown, this is A and this one is B. That is the conductor C1 is A and B, and conductor CT is C2 is C and D. Two coil sides are connected to slip rings, namely P and Q, and these two are connected to a load which will carry the current I, or I can connect the voltage across. Slip ring is attached to rotor and which is rotating one, and the brushes at the top of the slip ring, which is stationary, used to connect the load terminal into the coil sides. Here, galvanometer is used to indicate the direction of a current, or we may remove the galvanometer and we can indicate the loads like this. Tane is an elementary version of a winding. Many tanes are connected to form a coil, and many such tanes are connected in series to form a winding. Referring the diagram, considering a generator with single tane rotating in a uniform magnetic field with constant speed. As the loop rotates, the flux linking in the coil side AB and CD changes continuously. Hence, EMF induced in these coil sides also changes, but the EMF induced in one side adds to that of the another. EMF generated in a DC generator is alternating one, because any coil side under the influence of north pole will generate EMF in one direction, and under the influence of south pole the same coil will generate EMF in another direction. It is very important to understand any generator will generate an alternating voltage or current internally. For DC generator, through commutator we convert AC into DC. That is what in our earlier discussion we referred commutator is a mechanical rectifier. In DC generator, we keep the magnetic field system in stator and the armature conductors are placed in a rotor, meaning conductor is rotating and field is stationary. We can understand the production of dynamically induced EMF with the help of the coil position at different angles. we consider the clockwise rotation of a conductor rotating in a uniform magnetic field from 0 to 360 degree, meaning conductor is rotating in a space from 0 to 360 degree. Refer at theta equal to 0 degree indicates the position of a conductor with respect to magnetic field. The magnetic flux lines flows from north pole to south pole, that is this is north pole, south pole, and referring with respect to theta 0 degree, the coil sides are parallel. From this we can understand the plane of the coil side is perpendicular to the flux lines, but the coil sides are parallel to the magnetic field. So EMF induced will be 0, which is indicated at this position. So now the coil is rotating from 0 to 90 degree. So the coil is rotated at an angle. So the EMF induced is increasing. At theta is equal to 90 degree, the flux lines are north pole to south pole and the conductor is perpendicular. So the angle between the coil position and the flux line, so this is the flux coil side, 90 degree, which leads to more flux cutting action and the induced EMF is maximum. I am referring 90 degree at this point. And followed by the conductor is further rotating at an angle from 90 degree to 180 degree. So EMF induced is decreases and 0 at exactly theta equal to 180 degree. Referring 0 degree and 180 degree, both coil planes are perpendicular, but look at the coil sides. Here AB is at the top and CD is at the bottom, and here DC at the top and AB is at the bottom. That is, the coil side completes one half of the cycle of rotation. That is 180 degree rotation from 0. Earlier, the coil CD was under the influence of north pole. Now the coil CD is under the influence of a south pole. So EMF induced will be negative, and look at the EMF induced is increasing in a negative direction, and it reaches at 270 degree, reaches negative maximum, and beyond that conductor is still rotating from 270 degree to 360 degree. So EMF induced is increasing, that is from negative maximum to 0 value. Now the conductor completes one revolution from 0 to 180 degree and followed by 180 to 360 degree. Look at the EMF induced is alternating one. Between 0 to 180 degree, EMF induced is positive, and between 180 degree to 360 degree, EMF induced is negative. This we represent in a simple tabular form. Column 1 indicates the position of conductor and flux lines, and column 2 indicates induced EMF value, and description says about whether the coil sides are perpendicular or parallel to the flux lines and the respective current path. At theta equal to 0 degree, induced EMF is equal to 0. Both coil sides are parallel to the flux lines, so no flux cutting action. Induced EMF is 0. Correspondingly, the current also 0. At theta equal to 90 degree, both coil sides are perpendicular to flux lines, so more flux cutting action. Hence, EMF induced is positive maximum, and current flow AC to BA and galvanometer. Even we can replace the galvanometer with the help of a simple resistive load. At theta equal to 180 degree, induced EMF is equal to 0. Again, both coil sides are perpendicular. Both coil sides are parallel, hence no cutting action. EMF induced is 0 and current is 0. At theta equal to 270 degree, EMF induced is negative maximum because both coil sides are perpendicular to flux lines, hence more flux cutting action. So current flow is AB to CD to load. At theta equal to 360 degree, EMF induced is 0 because both coil sides AB and CD are parallel, hence no flux cutting action. Because of E0, induced current also 0. So we come to know that the induced EMF in a DC generator is alternating one. How do we convert that induced AC voltage into DC voltage? Referring our previous discussion, we may convert the induced EMF into DC with the help of a mechanical rectifier called as a commutator. Look at this figure, we use slip rings which leads to a collection of AC induced EMF. So this brush collects current alternatively, that is positive during the positive half cycle and negative during the negative half cycle. We come to know with the help of commutator. Commutator is the slip rings are segmented through mica insulation. So this is segment P and this one is segment Q. Look at this diagram. The conductor CD is to the left and conductor AB is to the right. After 180 degree rotation, the position of the conductor AB and CD are changed. AB is here to the left now and CD is to the right. Not only to the position of the conductor, commutator segment position also reversed. Now Q is here and segment P is here, meaning this press always collects current in positive direction and this press always collect current in negative direction. That is what shown this in this diagram also. So that leads to DC voltage across the commutator segment, or I can say the split rings ensures the unidirectional current flow in a DC generator. That is the purpose. We call it as the split rings or a commutator will act as a mechanical rectifier. Let us discuss the equation of electromotive force of a DC generator. Let phi being the flux per pole in Weber and Z is the total number of armature conductors. We house the conductor in an armature slot. So the armature conductor is given by number of slot into number of conductors per slot. P is the number of generator poles and A number of parallel paths in the armature, N armature rotation and revolution. Normally we indicate revolution per minute RPM. E is the EMF induced in any parallel path in the armature, e.g. EMF generated in any one of the parallel paths in the armature, average EMF generated per conductor, which is equal to d phi by dt volts. Normally EMF induced is, as per Faraday's law of electromagnetic induction, E is equal to N d phi by dt. We discussed earlier. Here we consider only one conductor, so N is equal to 1. Now, flux cut per the conductor in one revolution, d phi is equal to phi p Webers. Phi p Webers. Number of revolutions per second is given by N by 60. Time for one revolution, dt is equal to 60 bar N seconds. And as per Faraday's law of electromagnetic induction, EMF generated per conductor is equal to d phi by dt. Using the values of d phi and dt, I can write the equation phi pn by 60 volts. Number of conductors in series in one parallel path is equal to Z by A. So I can write EMF generated per path is equal to phi pn by 60 into Z by A volts. By simply rearranging the equation, I can write EMF generated Eg is equal to phi Z10 by 60 into P by A. P is varying, it may be of a 2-pole or a 4-pole or a 6-pole, and A depending upon the types of winding. For wave winding, the number of parallel paths always equal to 2. For a lap winding, number of parallel path A is equal to number of poles in a DC machine. Basically, the generator can be broadly classified into two types based on the output supply. It may be of a DC generator or an AC generator. AC generator is also called as alternator, which we will discuss in the higher semesters. Referring the types of DC generator, which is classified into self-excited DC generator and separately excited DC generator. Self-excited DC generator can be further classified into three types, namely series generator, shunt generator, and compound generator. Compound generator further can be classified as cumulative compound generator and differential compound generator, which is again classified as long shunt and short shunt in both cumulative and differential categories. So far, we have discussed about principle of operation of a DC generator. Yes, DC generator internally generates AC EMF. With the help of a commutator, we can convert that AC induced EMF into AC induced EMF. Followed by, we have derived an equation for EMF induced in a DC generator. In the next class, we will be discussing about connection diagram of different generators and its characteristics. Thank you.